The Giza Plateau, home to the most magnificent monuments on Earth, a pinnacle of human achievement, and a landscape wrapped in layers of mystery. Since the time of Herodotus, tales have circulated about hidden labyrinths and underground chambers beneath the sands of Giza, whispered by ancient wisdom keepers and echoed in modern times. Wow. What do we discover?
That's the original door, but then you see the statue and you see the hieroglyphic up.
Would you say this is a marker for a shaft?
Shaft.
Ah, this is what I was curious about.
My amazing husband and I have our own stories to tell, because together we have ventured into the subterranean world beneath the pyramids. We have experienced it for ourselves, and we know that it exists.
Into NC2, Tomb of the Birds, Cave of the Snake.
Ladies and gentlemen, this is it. This is the entrance into the subterranean underworld. What looks to be a human bone of some sort there.
Didn't see that last one.
Yeah, didn't see that last time.
Oh, this is incredible.
The same part. Here, come on.
Okay. I'm Lex Levy, and this is Ancient Odysseys. I'm here in the subterranean chamber, all by myself in the dark.
But could there be something more buried below? Something vast, something unimaginable?
Central Pyramid. Great Pyramid. All its way. Possibly something below the Valley Temple and Sphinx.
Today, we are diving into one of the most controversial and cutting-edge investigations on the Giza Plateau, the Khafre project, SAR technology team, using proprietary synthetic aperture radar Doppler tomography technology to scan deep below the Giza Plateau.
This is the Osiris shaft. The Osiris shaft.
Subterranean third and lowest chamber of the Osiris shaft. Into the northwestern corner, you can see the tunnel.
Their astonishing claim is that beneath the pyramids lies a vast hidden underground city, stretching beyond a kilometer beneath the surface. Chambers, voids, and unexplained structures that, if confirmed, could rewrite the history of ancient Egyptian engineering.
You think there's a passage?
Yes. Well, you can see that this was
Yes, it's like it's just fitted right in there.
Never more city. This underground here, madam, about 100 meter ground. Ground underground here.
How deep?
About 100 meter ground.
100 meters.
Somebody has same, you know.
Where does it go?
On the ground. There, big city.
Big city?
We are going to break down the technology, examine the evidence, and explore the skepticism. What exactly are the limits of this scanning method? And what is truly being detected? To get answers, we traveled to ancient Malta, where the Khafre project team held their first international press conference. There, we met the brilliant minds behind the work. Corrado Malanga, independent researcher and author. Armando May, Egyptologist and author. And Filippo Biondi, the inventor of the SAR technology. We found the Khafre project team members to be welcoming, passionate, and generous with their knowledge. And we had a lot of questions. A major question I have is, what reference or calibration standard was used to validate the SAR system? And what are the defined range capabilities and accuracy tolerances, given that any inaccuracies would be amplified over long distances? How are those potential errors minimized or accounted for? So, let's get into it. Is the Giza Plateau ready to reveal its greatest secret yet? Are we on the verge of rewriting everything we know about ancient history? Let's find out.
And this is Ancient Odysseys.
Here's the boys. Say hello to everyone. Armando, Filippo, Jay from the Project Unity, and my wife Alexa, Ancient Odysseys. And they're about to break it down. So the melding of the minds here in Malta, very exciting stuff. Let's go. So they were creating chemicals on a massive industrial scale in the Step Pyramid, Red Pyramid, Bent Pyramid, Great Pyramid, and Central Pyramid, which were all directly involved in agricultural fertilizers, fuel sources, and then mining of various metals and gold on the Giza Plateau. Thank you. And on the inside, so for example, inside of the tombs, there's a lot of decoration and hieroglyphs and stuff in there that people got buried with. But inside of the pyramids, there's nothing. There's no hieroglyphs, there's no decorations, there's never been any treasure discovered. So why didn't they put the names, at least, of the people that were buried inside of these things?
And what's your thought?
So I think that they are engineered to make chemicals, chemistry. Inside the pyramids is chemistry.
So you're telling me the people lying there, there were machines, they created machines.
Yes, big machines. Yes. All right, so they're preparing for the slideshow, and I just see them scrolling through the deck of information, and they have a ton of data in the slide presentation that has not been made publicly available yet. So there were several things that already caught my eye. We're going to be able to ask some questions directly to the team. As you know, in my previous episode, I expressed my excitement, enthusiasm, but skepticism about what has been presented thus far, and I had some questions about not only the data, but the extrapolation into the 3D models, some of the methodology that's involved. So again, we'll get a chance to actually talk to these guys and hear their explanation, and hopefully clear up some of the potential issues with the scanning technology, and I'm really excited to see what happens. Generally speaking, they seem like really nice guys, and I'm certainly very encouraged about the idea of the implementation of new technology for the study of the Egyptian pyramids, because I think it's critical that we utilize all of the techniques that are available to investigate these structures, because clearly the conventional methodology is getting us all of nowhere. So this is a very exciting conference and meeting of different individuals to be participating in. Got my wife Alexa from Ancient Odysseys. Again, Jay there from the Project Unity. We just got a chance to meet. So this is going to be awesome. Let's go.
The presentation that we are doing of this RF in Malta, and it is a bit technical, so don't worry with you see some numbers, some formulas, but I think that we have to move to an academic procedure in order to comprehend what we are doing in this research. So this research is highly technical, and just to have a brief information about the things that we are going to say this evening. So it is a lecture structured. So here we are saying also some technical details about our technique. So this is the agenda. It is a bit long, but I know that this evening we made a bit late, so we try to fit everything. Synthetic Aperture Radar. Synthetic Aperture Radar is a radar that is located on a carrozza that is a satellite, and this satellite is shooted into the space by a space leap, by the space, by a rocket. And so the radar produces images. The images are produced belonging the radio frequencies, and the radio frequencies are standing inside the 30 Hz approximately, per SRP per that is proportional to the resolution. So the spatial resolution is this, and is this one here, delta, and is measured in the meters. It's equal to lambda, which is the wavelength, times r. It is the distance, the satellite target distance, over 2 times the aperture. Synthetic Aperture Radar, the more the aperture and the better is the spatial resolution. The spatial resolution is a physical indicator that measures the capability to detect separately 2 targets. Okay, so it's a minimum distance or which 2 targets can be separated by the measurement system. Okay, and this is proportional to the aperture. The aperture can be intended like the telescope of aperture, no, or the aperture of a microscope. So any measurement system that produces an image is characterized to have an aperture. It is very important. This my phone. You have your phone as a camera, no, on your phone. The camera has an aperture that makes photographs, and these photographs are encoded having a certain resolution according to the aperture. So also the radar is a camera, but is a different camera because the images are encoded, are produced according to the orbital evolution of the platform. The orbital evolution is because the satellite, when it's shooted into the space, is shooted with a certain velocity. And this velocity, we have the satellite that rotates around the Earth, pole north, pole south, north pole, south pole, and it belongs 90 minutes to make this revolution, north pole and south pole. According to the maintenance of the orbital angular momentum of that is a basic physical law, this rotation is constant. Okay, it has a constant orientation, and inside this ring, the Earth turns during the day. Okay, so every day the satellite is capable to watch at least one time all the Earth. So this is, let's say, Synthetic Aperture Radar is very important to make Earth observation for civilian application. It is very important. So we can scan the Earth, and so make images, radar images of everything of the countries, the cities, the vegetation for any kind of application. Synthetic Aperture Radar works like that. We have here we have the platform that moves, and this is, let's say, a target. The target is illuminated by electromagnetic pulses, and the target will give us the response. The response produces the so-called raw data. This is raw data that are just the echoes that we have at the receiver. The receiver is capable to have the echoes, and so the echoes are stored inside the memory, and we have the raw data. How to pass from raw data to focused data is a so-called focusing process that is divided in two. We have range focusing, and azimuth for focusing, and so with passing through motion compensation, we can recast the photo of the target. This is from here, the target, and we have the photo of the target. And so the image is, in this case, a point target. Of course, Earth is full of scattered point targets, so this is an image that is very nice, in my personal opinion, and I can say that this is a Capella space image, and I thank Capella to because they gave us for free this image. We can see that is a colored image because we have used the 3 Doppler bandwidths in order to have a color composite image, and in this case we have a colored image. These are the pyramids here. You can see that this image is a bit different with respect to an optical image because we had a different kind, a different mode in order to project the image. This is a focused image. This is very similar to an optical image, but this is radar. So, just to tell you, we recast about the state of the art of synthetic aperture radar. Synthetic aperture radars are used for monitoring the Earth, infrastructure monitoring. So we can, for example, monitor the dams here, and also earthquake monitoring here. Why? Because it is very important that radar data can be used building in the space an interferometer. The interferometer is a particular device that is very important because with interferometry we can transform the phase information of radar into something that we can use by to make topographic reconstruction. This is the phase. Topographic reconstruction is used to perform infrastructure monitoring because radar is very, very sensitive. It means this. We have this object. This object is here. We are observing this object from the satellites. The satellites are flying in the space at 600 meters. 600 kilometers of distance with respect to the surface of the Earth. And if the target moves also of 1 millimeter, the radar is recording these movements. So the state of the art of our synthetic aperture radar is this: we can detect the physical displacement of large infrastructures. That's very important with millimetric precision. Just to show you, this is the Postful Dam, which is a dam that is located in Iraq. Vabbè, lì should have a short video, but it is not important if it doesn't work. According to a technique called persistent scatters interferometry, we can detect the physical displays, the physical distortion of large infrastructures with respect to time. So, according to a persistent observation of critical infrastructures, we can perform infrastructure monitoring. Okay, we can use radar and synthetic aperture radar also for monitoring the oil extraction in order. Why? Because maybe we are observing this place of the earth. Here we have a crude oil plant extraction. While we are extracting the oil, we can see that the surface of the earth, we had a subsidence, millimetric displacement of, because we are emptying this pocket. And so we are, it is possible to observe also the monitoring, let's say like that, the oil extraction. Okay, so this, since now I explained you the state of the art of radar, and here we are maybe in 2019, where with Corrado Malanga, we were studying in detail the pyramid. This is a radar image, two radar images of the pyramid. We can see that the nature of the images of radar that is different with respect to normal optical images, but we can consider that these are very good photographs. And just an example, there are two types of image projection: high layover and low layover effects. So we noticed that every photograph is affected by motion. Because nothing is fair. Everything it moves happily. So we tried to estimate these movements here that is naturally embedded inside the synthetic aperture radar images. Doing this, why we wanted to do this? Because the vibrations, we noticed that the Doppler information that we use to focus synthetic aperture radar images recast inside the acoustic bandwidth, which is very important because acoustic information penetrates very with very much the matter, and so we were interested to watch inside the matter. We used a software that was based on the so-called Doppler subaperture. So look here, we have we started from the raw data. We designed some filters. Here you have the frequency, as in frequency and the range frequency. The range frequency that determines the range resolution that was catched entirely. We made some planking on the azimuth orbital information, and then we produced this sliding window with the frequency in order to transform a static image into a frame rate having a lower azimuth resolution. Doing this, why we did this? Standard SAR processing methods are basic upon the so-called stop and go approximation. It means that here we go back. If the target that is located on the Earth moves, in this case, not with a little millimetric physical displacement, but with a sub-millimetric displacement, so it means also 1 meter of physical motion. In this case, the radar will record this information in terms of Doppler centroid anomalies. Okay? So in this case, we found a method to transform electromagnetic impulses, so the physicists call these photons, into something that are recast inside the acoustic information resonance. Yes, sound. Okay.
Goes much deeper than light.
If you have some question, you can also interrupt. So, we found also that there is a phonon interaction, because everything that is transmitted with electromagnetic energy and interacts with matter, this interaction will produces, yes, a backscattering energy inside through the receiver of the radar, but also the production of physical vibrations. Okay, that is very important. So we have designed a method to transform the information that has a light nature and electromagnetic nature into vibrations. So this is a vinyl reader here that I am very interested in vinyls. In this case, the electromagnetic transmissions can be associated to this device here, and the vinyl that turns is the earth. Okay, so this is a very okay. Our technique, yes, has been. I put this slide not to say that the community that we have patented this technique that transforms electromagnetic waves into acoustic information, but we have submitted the patent in Malta. So that's let's go with design.
So
Okay. The first experiments that we have done using this technique were devoted to perform infrastructure monitoring. That is very important. We go back in 2019, where in Italy collapsed a very important and let's say historic bridge with two spots located in Genoa, the Morandi Bridge. When the Morandi Bridge collapsed because assumed a very dangerous resonance frequency due to a storm, no? And so we found that the technique that recasted the state of the art synthetic aperture radar, so persistent scatters interferometry, could be failed in performing bridge monitoring. So we had to design a new method to find anomalies, vibration anomalies on bridges. And so we found this. Look, here we have accumulation of energy, which are vibrational energy accumulation, where the cracks on the bridge are present. We moved also, this is a radar image that is overlapped to a Google Earth image, and here we find the backscattering information due to the cables, the highly voltage electric cables. And so we tested this method in order to estimate the vibration, the 50 Hertz vibration. I don't know if you went, you should never go under the PLC. You say the ripple, so you are saying the ripple. The listening of this noise, it means that you have the physical vibration of the matter. This physical vibration has been detected by radar, and we have the physical vibration that we have measured from the space. This is the spectrum of the physical vibrations that recast perfectly inside the 50 Hertz. The 50 into the 50 Hertz of the electric lines. Okay, so our technique is also able to perform activities like crude oil pockets detection, because this is a prospection of the Earth, below the Earth. These are, here we don't have the legenda, but it is 5 kilometers this below the Earth, so it is very sensitive to go below the Earth, and these are the stratification that we found of the soil stratification. And this is a vertical crack of the Earth. So this is very important, just to show you a potential nodal peak. So I showed you that our solid technique, that is, it is extremely oriented to science, began in laboratory. This is my garage, and I show you that there is some wine here, but it's avoid here have some mess, that is inside my garage. And so we did a simulation. We started from some water, a camera, and a computer. And here we then an initial image of our satellite. And then we have this is the Earth. We have some, let's call some a space where we don't have matter, so matter, not matter, and matter. And here we have, this is the vibration generator, and this is the camera that catches the images. And so we began to perform vibrations, no? And these vibrations put the water into motion. This motion, we recorded this motion. So this is the raw data of the vibration. And this raw data has been focused in order to retrieve the picture of what there was underneath. So we can retrieve the shape of the table, this X at the cast on us is a token that we are to performing the images. Okay, so from the laboratory we passed to the space. Once that we knew that it was possible to retrieve the acoustic information of what was below the table, the water, we passed to make some experiments by using satellite. So this is, we moved to United States, and this is the Carlin Tunnel that is located in United States. In we have several tunnels, and we tried to watch, to follow the inside this mountain the tunnel. Okay, and here we started to perform some images of what was present below the Earth and inside the mountain here, and here, I'm sorry, and here. This is the picture of the tunnel that we are depicting from space. Look how it is clear, the representation of the railway tunnel that is inside the Kari mountain. Okay? Then we move also on another target. This is an important mountain that is located in Abruzzo, where I born in L'Aquila, and that's my CP. And inside the Gran Sasso, this is nearly 3,000 meters tall, 2,994 meters tall. And in the core of this mountain, there is a physics laboratory. The physics laboratory is characterized to have vibrational tools inside, ventilators, machines, so they produce the vibration. This is the schematic representation of the laboratory. And we concentrated our attention on this here. This is an interferometer of laser that is inside the evaporator. I give you the representation of the mountain. This is the tomographic. It is one of the first tomographies that we have retrieved. So you are seeing it a bit noisy, yeah. But inside the mountain we can observe that there is it is called tratto del traforo del Gran Sasso. It is the piece of tratto, the tunnel that passes inside the mountain. And here we have the depiction of the laboratory. Here, the laboratory, and this is the interferometer. So it is scientifically proven that our technique works, because in this presentation I stress everyone to take attention that we started from laboratory and we are passing now to the space. Okay. So then we have moved to scan inside other things, other infrastructures. This is, we go back again to the Mosul Dam. This is the optical image of the Mosul Dam, so we can pay attention about the difference standing between an optical image and a radar image. It is still an image, yes, but it is different because it is black and white, a bit more ugly, a different projection of the pages. But I can assure you that this data is more rich with respect to the optical data. Then we have applied this technique in order to scan inside this infrastructure. This infrastructure has been that's only has been maintained by an Italian company which is called the Trelli, and they performed concrete injection on this infrastructure. We can notice that inside this infrastructure there is a tag that passes through from one side to the other side of the dam. So this we are detecting the dam below the structure. We are detecting the concrete injection that made that the Trevi company made in order to stabilize the dam. And then we are also detecting the inside fissures, electrical fissure, the turbines that are inside the dam, because it is also an electric power plant. They are located inside here, an electric power plant, and so we can see that it is possible to retrieve very, very precisely the shape of, in this case, this is a Kepler two-pin. We have two kinds of two-pin. A Kepler with a two-pin, which is a vertical two-pin, and also another kind of two-pin, I think it's called the Francis two-pin, that is horizontal. This is the Kepler two-pin. Okay. And also this under two-pin here, that is this, I have to move a bit far away because you do not see it. This is the Francis two-pin. Okay, this is the tomographic scan of inside, what it is inside the Mosul Dam. And so here, this is an augmentation that we made together with Corrado. So we are moving slowly and to arriving into Giza, because we have to know from where we have started and where we are going to arrive. So we moved also to scan inside very huge mountains on the Alps, which is the Gotthard tunnel, and we have detected the pieces of the Gotthard tunnel, which is a railway tunnel, here, using this technique. Okay. So now we are this picture was cited by Joe Rogan because it was published by Stacey Liberatore that she writes for the Daily Mail. And in the press conference that we made in Bologna, we gave the attention about the known structures that because we are concentrating in depicting the known structures that are underneath by our technique. This is the Osiris shaft. The Osiris shaft has this particular shape. We have a multi-layer shape, and according to this slideshow, we can detect very precisely the shape of the Osiris shaft, and we are watching. According to this tomography results, we can understand that the supposed shaft is going down more with respect to the scam that we know that can be. Okay, and we can see this anomalous structure here that is located 2.5 times more deep with respect to the known structure of the Osiris shaft. Yes.
So I have a quick question.
Yes.
So we live in Egypt.
Yes.
And we have spent an extensive amount of time on the Giza Plateau, and I've been in the Osiris shaft on a number of occasions.
Yes.
So the Osiris shaft runs below the causeway that leads from the central pyramid down to the Sphinx. Can you explain where is the causeway on this image?
What's the causeway?
The causeway is the connection from the Eastern Temple adjacent to the Central Pyramid that runs down to the Sphinx.
Yes.
So the causeway is a limestone structure that's made of both bedrock and large blocks of limestone that connects the Central Pyramid down into the Sphinx.
So this causeway, in which depth is located?
Surface.
So, but the surface is the surface.
Correct.
We have enhanced the view of this. I will send you the original. This is very important.
Yeah.
Question.
Yeah.
It's very important, right? Because I show you other results where we see this limestone that you are saying. Thank you for giving me this question, guys. I
have many more. So now let me ask a secondary question. So the causeway itself is visible on other scan data, but this one is calibrated to subsurface structures.
Exactly.
Okay.
You aim there is because you are English, and so sure.
And I'm happy to help in the future.
Because
yes,
if your but this result has been tuned in order to watch only the things that are below, underneath, and we have canceled this because they produce aberration. So you watch only that because it is very high in terms of energy or vibrational energy. Okay.
Okay. Second question.
Yes.
Can you explain, so according to the conventional archaeology,
Yes.
the Osiris shaft is unique in its descending down into the bedrock.
Yes.
So it's the only feature that is known on the Giza Plateau
Yes.
adjacent to the causeway that goes underground.
Yes.
So in your image, what is the signature on the left?
This one.
Correct.
This one.
What is that?
Yes. We have to. It is.
Something new. Okay. Okay. Fair enough. Okay. So I will say that along the causeway, so there is a transverse passage that runs from north to south below the causeway that is the opening and entrance into the Osiris shaft. And there are several other of these transverse openings on both sides of the causeway in several different areas. So that it's certainly possible that there is something there. Yes, yeah.
We can track precisely on these objects, but remote service not only about scale, but different scales.
Yes. Okay, so now my final question for this point.
Yes.
So at level 4, that is where the Osiris shaft
Yes.
taps into a subterranean aquifer.
Yes.
That is the water table below that particular structure.
Absolutely.
And I believe that it's an independent aquifer. We have chemical analysis data that shows that it's somewhat salt water. It's brackish water, has a very small content of sodium chloride. So it's an independent aquifer that's located directly below the Osiris shaft. How does the water table, and this has been one of the main criticisms levied against the technologies, is the inability to scan below the water table. So how can you just clarify a little bit what we're detecting there below the third chamber and how the water table might affect those interpretations?
Thank you for this question, which I don't give you in this slide the exact answer because, as I told you before, we have enhanced some covers in order to make you see the exact shape short the Osiris shaft. Okay. But I give you in your the response of the answer of your question in the other tomographies. Okay, I will show you and show you the difference between what there is, let's say, dry and the things that are below the water. Okay, I will tell you the physical, and I will show you it. I will demonstrate you the physical phenomena that happens.
Okay, very good. Thank you.
I have a question.
Thank you, but
How did it create that hole under it?
I please ask you to repeat it. The question.
Yes.
Sotto, come si è creato quel buco?
The study is about that. This is a anomaly in terms of vibration energy. Okay? Because below the earth there is something so hot that resonates a lot and give us on the top high energy. This is because of this is a manipulation of colors. You will see it black, but in reality it's red. High energy.
Okay, it's red.
So one more quick question related to that topic. So on the Giza plateaus, there are a variety of different mineral deposits in the bedrock of the Giza plateaus with different densities.
Yes.
Are the readings of the radar technology capable of picking up different densities of material? For example, like you were saying, the big signature at the bottom of this image is picking something that possibly has a greater density than the surrounding limestone.
Absolutely, yes.
Okay, I think this is also very important in understanding what's happening on the Giza Plateau because there's significant mineral deposits specifically related to iron ore minerals that are below all of these structures. Okay, so another question. I want to be able to understand this. So, for example, when we're looking at this raw data here, are we looking north to south
No.
or east to west?
My fault. It is my fault because we compile a scientific article that will be accessible in preprint very soon. And here, purposely, I did not put north, south, east, west, because we are recasting precisely the coordinates, so we are scanning the old tomographies, and so we have to still put the coordinates, and here we put the height and the cosines. It's my fault that I did not put the code.
It's okay. So again, I'm trying to make sure.
I remember. And then there is, let's say, the Khafre pyramid. There is the Sphinx.
Yes.
The Osiris shaft, I think, is here. And
Correct.
Very expert.
Correct.
But I think it's here.
Yes.
So the tomographic line is like that. Okay. East
Okay.
and west.
So this image is looking north-south.
Yes.
Yes. With the causeway running from west to east along the top. Yes. Okay. Okay. Very good.
I'm sorry.
Oh, no, it's okay. It's okay. Be prepared for more. And I'm sure you have the answers. Yes, this is very good. Okay. Please continue. Yes, yes.
No, you can't.
Here we show you also past results concerning but I show you this because this, I think we saw, everyone saw these results, but only to show you other validation of noble structures. So this is the Z, the tomographic result, and Z that is present inside the morphoclears. Okay?
Oh, hold on 1 second. Before, why the
Then, and then, this started here, and I say today, say, this is the very famous corridor shot or 9 meter things. Look, it's 9 meters corridor that Professor Zakiawas discovered inside the small boat. Yes, the shadow. So below, behind. Yes, behind the shadow. Okay. And then you can see inside in the videos that shows the camera inside this short corridor. There is a room. So a room. Yes, it is a room. Here is a roof. Okay. So when Professor Zakiawas will discover the room, here there is the video. Today is which day is 14. This is the room. Okay.
Okay. So on the image on
these slides.
Yeah. Okay. And I have 100 questions.
Okay.
So on the image on the bottom left, we can see a signature indicating the that entire image.
This is the big void.
The big void. Yes, that's what I saw.
The big void. This is the big void.
Correct. Okay.
Okay.
Okay. So we can see a signature there highlighting the area around the Queen's chamber. The Queen's chamber. Yes, this one. Correct. Yes. We have a good signature from the radar showing the Queen's chamber. Why is there not a signature detecting the Grand Gallery?
Okay. I tell you the answer.
Okay.
Please watch the video of Professor Emilio de.
Okay. So on the image,
We can see these lines.
100 questions. So on the image on the bottom left, we can see a signature indicating because yes, that
The entire here see the big void.
the big void. Yes, that's
Not the big void. This is the big void.
correct. Okay.
Okay.
Okay. So we can see a signature there highlighting the area around the Queen's chamber. The Queen's chamber. Yes, this word. Correct. Yes. We have a good signature from the radar showing the Queen's chamber. Why is there not a signature detecting the Grand Gallery?
Okay. I tell you the answer. Okay? Please watch the video of Professor Emilio Del Giudice. Emilio Del Giudice. Emilio Del Giudice.
Okay.
Is a fee del once somebody told him, Professor, why? I documented the question. Okay? He gave this answer. Why? Why? E perché? E no. E so repeat it. You can take
What a question and take the answer.
You don't have the answer. I don't know.
Okay.
I don't know.
Good. Okay. It's just
Yes. Would do it.
and it is a mark of a good scientist to be able to admit when you don't have.
Anyways.
And it is a mark of a good scientist to be able to admit when you don't have the answer to any specific question. I've heard it proposed that it's due to the angle and the orientation of the grand gallery.
Due to the angle, to the particular tomographic line. Okay. I have a lot of tomographies where you see very well the grand gallery. Okay. You don't see it. I'm sorry.
It's okay. No, I'm just, again, I want to be,
I tell you, but sorry, not to you. And but because it's like that, science is like that. You don't always observe things that you expect to observe.
Yeah.
Right. Okay.
right.
I challenge you. You have to do 60 slides, but it's important to stress in this. I want to remember Italian scientist Enrico Fermi. Enrico Fermi used it to say this. Their rettore, to Ettore Majorana. Their rettore, because he was his scholar at Majorana. Their rettore. When you perform a measurement, and your results are compliant to your expectation, you did the measurement.
Right.
Exactly. If your measurements are not compliant to your expectation, you performed a discovery.
Exactly.
Okay.
No.
Six. So, well, this is the archaeologist. The shop corridor and more. Yeah.
Make your opinion of you.
We respect a lot Professor Chapiawas. We respect a lot the paper that they published after our publication. We chided him, but he did it chide us. Is not a problem. Just to say, on parler. Okay? On parler. So, I show you other things that we are doing. We are working on. We moved to work on Khafre pyramid, but also we are working also on other things here, and we are fetching, we are fighting, and you will appreciate these things on the scientific article. And so we can do now a short recast of what we, and at the end we will show you known things, absolutely, and I still have to give you the answer of your question about the water that is underneath. So this is the some initial tomographies that we made on the Khafre pyramid here, and we just began starting in watching some structures that we didn't know anything about the shape and what were these structures here. But continue, this is the datum here. The datum is the surface on the earth. These were the initial tomographies that we was performing on the Khafre. Up inside there was some planet targets that we could detect inside this infrastructure. But going deeper inside the processing, so passing time, we was able to detect other detailed structure located inside the pyramid, but not below the earth, from the bedrock to the top of the pyramid. This is an horizontal scan that we performed interpolated to several vertical scans that we made of the Khafre pyramid. And so with Corrado, this is you can see this on the video of the conference that we made in Bologna, where Corrado explains very well of this procedure that we did. So I don't want to repeat things that we just we. But it is important to stress this only to remark the fact that we are using the scientific approach, so to track into space, to track into space the daggers. Okay, so let's say target 1 from here, we recognize it here. Target 3 from here, we recognize it here. 1, 2, 2. So we can track into the space different targets. Okay. Here we move on this tomography that I like to propose you. This is Capella Space. Capella Space is an American SAR company, and we are scanning the entire depthness of the Khafre pyramid. So here we have the datum is here on the top like that. So maybe here. So from the top to here is Plateau pyramid. 137. Just as the answer, the diet. So just actually it's not in the original. So 137. And then how many 137 in order of depthness you had from the top to the datum, and so scanning it all. Here we are detecting the pillars here from the top to the ground here like that. And you can notice from who is far away from this screen that there is a spiral nature here that attracted our attention about the pillars. That's very pop. Like that. Look, here this is absolutely visible and here like that. Okay. Come? No. Oh, dopo. Grazie. Perché mi piace. And here also you can see this nature like that. It's very important, this. Okay. They are private, yes, I know. It's we can't have perfect images, very detailed images. We are watching ticks from space from 600 kilometers of quarter, of height. Okay. Here are some details about the 5 exits yes.
So you mentioned before that when this technology is implemented for detecting geological reservoirs of petroleum,
Yes.
the radar can detect the subsurface strata and fluctuations of the densities of the bedrock.
Yes.
If you go back one slide,
Yes.
is it possible that this is also a signature of bedrock density or geological strata?
No.
Okay.
Because the previous image that I show you was made with the part of the software tailored to have that.
Okay.
This is tailored to have the retrieval of the let's call it alternation of high density, low density. High density is different. It's a part of the software that is different. Okay, it's tailored to have this I don't know if I explain.
Okay, so
What?
the software that generates this image
Yes.
is calibrated to eliminate the fluctuations that would occur in the bedrock and to detect things that are abnormal within the bedrock.
Absolutely yes.
Okay?
Hmm?
Okay.
Okay. Thank you very much. That's a good point. And yes, because I can calibrate the software to find the structure, the man-made structure, and I can calibrate the software to use it for both for using it to detect pockets or through the oil to make other things. But this calibrated software, find that kind of nature of the targets that are located under it. Okay, here we go back again, draw the data to the top, so we are inside the Khafre pyramid, and only to show you some details of the structures that we found inside that are like layers. So they can be we can think to be similar of the Z that is located inside the prefix pyramid. But here a bit less, maybe, but something later. But it is very important that case structures are connected directly to the shards, like that. They are connected. They are encapsulated. Okay? Here we are counting also 5 layers that are composing these structures here, and the dots of that has there is.
Okay, so I have another question, and I apologize for all of my questions, but I have been pretty diligent in studying both your initial paper from 2022 and also the new findings. And one of the criticisms of the new findings, so in the image on the left, for example,
Yes.
we should also expect to see the Belzoni chamber,
Yes.
the lower chamber,
Yes.
and the series of connecting shafts that link those chambers are excavated directly from the bedrock limestone of the Giza Plateau, with the exception of the ceiling beams of the Belzoni chamber, which are limestone masonry blocks.
Yes.
Can you clarify what is the explanation for the software not detecting the known chambers at this stage? And I saw, Armando, you had made a post on Facebook regarding the potential of a, quote, limestone slab that may be different from the bedrock limestone of the Giza Plateau itself, that was somehow interfering with the signal and the detection of the known chambers. So again, there should be 2 chambers visible somewhere in the image. Can you elaborate a little bit more about the detection of the known chambers and why you think that might be the case that we aren't able to see those in these images?
I will thank you for this question.
Yes.
Una premessa, come si dice?
I promise.
Promise.
Yeah.
I will make we make it Ross. Oops. Everyone will ask ourselves how much time physicists inside the Grazzasso laboratory, for how much time are trying to observe the Majoral Leontrino. They know that there is, but they can't observe it. Okay? This is only to tell you that expectation on measurements are not always satisfied. And maybe the answer to my question can be given by Sabine. Okay? Sabine will give you the answer. Okay. But this is the phrase, the prompts. But now I give you the answer.
And
we found two tomograms where I don't have it here, and I'm sorry, but I will send it to you via email, where Corrado fatto delle Belzoni chamber. The Belzoni chamber is a bit small, and in Italy we say non se può capare sangue dalla lapa.
it's impossible.
Means that something, if it is not possible to extract blood from a geralta, a parva piedola, okay, a better language, it means that when you intend to expect a result from a measurement, sometimes you will never find that measurement. That's why I am citing the physicists. So, because they are fetching the neutrino Majorana. I'm still waiting it. And so, Sabine, we give you the answer. Okay. Yes. I don't have it yet, and I'm sorry if I don't. It's okay. I'm not very. I'm sorry. That the bedrock.
So why is sometimes you add, sometimes not, depending on the configuration of the software, or
No, it depends on the orientation of the tomographic line. It depends on a lot of things.
also the different satellite to the digit sites.
Also in the material that I'm saying too. Achy, because we have and we don't have it because of the orientation of the tomographic line. Please, for people like that, you don't observe. You observe nothing. If you move a bit the tomographic line, it is favorable to have also the mezzo observation.
Okay.
Yes.
How long does it take to take 1 inch?
We were telepathy, because the problem is, okay, why don't you use a tomographic line where you can see the Belzoni chamber? Yes, I know, but to have this result, we have to spend 3 weeks, no? And in 3 weeks, I forgot also how to, because we have to do pixel by pixel scan in order to have the Belzoni. 3 weeks, and how much time I have to wait, okay? But I have it, and I will show it to you. Okay. Other results, only to show you the pillars, the physicists that are going. Why we are not watching 8 pillars? Because we have to scan tomographic lines for tomographic lines, in order to see inside, in all dimension, inside the matter. But to reach into these results, we have to spend efforts in terms of processing time. Many, as we said earlier with Corrado, we are doing this without money. Okay, we have only 2 computers here and enough. So, I'm sorry. Okay. I go a bit faster, just to show you other results where we have depicted the pillars, but I want to concentrate these things on the pillars, because these pillars I like them a lot. So this and they go below the head, where we are seeing structures that are characterized to have angular 90 degrees angular shaped structures here below the earth. Okay. But now I show you other digs. This is Khafre, yes.
The genres you mentioned, they are in water or there is water eta?
I collect your question and I answer when together to you and to you, because I show you the results where the water is taken into account, probably, because here you are doing measurements with a certain probability. It was measuring it beats statistic. Where is the engineer? Here. The engineer. Okay. This is Khafre. I'll show you the pillars of Khafre. So here, this is the, so for this is Khafre, tomographic line. Here we have the orientation, 1, 1, 2, and 2. These are the pillars that we have detected. This is the surface, the limestone. How is it? The sepia. Yes. As it were. Please ask me the question, Filippo, why we are not seeing the top of the pyramid? Why? I want to curious this setup question because we are using the particular SAR image where we have a very exaggerated layover of effect of the pyramid. So where we have an exaggerated layover of the pyramid, we are not watching the top of the pyramid, but it is tailored to scan very straightly underneath. Okay? That's very important. So here we have the pillars, and here we are concentrating our with Corrado in these days to this part of the pillars and this 1 and 2. Here we have the pillars, here we have the at the spiral nature, and we have a core on the center of the ganas. Yes, very important. Okay, later the cause of the also daisy of the shafts, and here we have the nature, spiral nature of this. So this is another answer that I give personal to. The personal answer that I give into Sakine. Very important. Okay. See, please. Water. And water. Look here how bright is this. Here, and then the brightness is collapsing abruptly. Okay? Probably here, from here, begins the water. Oh. Yeah.
And how are you sure about this?
We have to dig and go and measure directly. This is the only.
All right, everyone. I hope you're enjoying the video. And if you are interested in the ancient technology of a lost civilization utilizing physics and chemistry and the function of the Egyptian pyramids and other ancient structures from across the world, please remember to subscribe to the Land of Chem here on YouTube so you don't miss out on the new episodes that premiere twice per week. If you want to help support the channel, check out thelandofchem.com. You can pick up a copy of the book or grab some merch, link in the video description below. And if you want to get access to exclusive research videos, check out the Land of Chem members only channel, now up to 22 absolutely massive research episodes that also feature some unreleased expedition footage. Ladies and gentlemen, as always, thank you all so much for the support. Now, back to the video.
Imagine they are going to edit. Oh, he will help us to do this. Okay, if they don't call me, I go inside the house. Here we go deep. You see, Armando, you can send me down. No worry, I have no fear. I can go. Look, water. Yes. And here we have the rules that we announced to the press conference. 1 and 2. 1 and 2. This is very important. Look here. We have performed a augmentation of the software because now we are processing also the polarimetric information. The polarimetric information takes into account also the orientation, the physical orientation of a vibration. In this step, electromagnetic waves are polarized. Polarization indicates the orientation of the electric component field of the electromagnetic waves. So we can have electromagnetic waves, vertical, horizontal, and also circular as we want. Okay? SAR images are also polarimetric in the electromagnetic sense. Here we have made our tomographies polarimetric in the vibrational sense. So it means that the vibration you can have horizontal polarized vibration, vertical polarized vibration, or other type of polarization. And according to this, we have installed, we are showing the vibrations on 3 channels, 3 polarization, horizontal, vertical, and oblique. Okay? And here,
Sorry, so it feels like a telephase.
see. Yes. This is a cold composite code. The so-called Pauli representation of the information. I told you this evening is highly academic, this lecture. So take all the questions that you made. I appreciate a lot also your questions. But here is important. You have an abrupt degradation of the energy where we are observing the pillars. Here, I think that this is the confine, come si dice? Chorus, the babine capacity of the water, of the water. I'm sorry because I'm also really tired.
It's better to put on the AC, I guess, because it's getting stuff in there.
Afna tired, come si dice? Aiuta. Menkaure. Pillars. And Ruby. 1.2 kilometers below Menkaure.
One people is
Menkaure spiral nature. Here. The room, please catch a photo here. The room here below Menkaure, J. Ecco the room. Poi c'è qua.
I have a question. That was just Cora.
1.2 kilometers.
How big is this room?
This is like Menkaure. This is like Menkaure. The size of Menkaure, yes. This size of man.
Oh, wow. That's big.
I have a question. How did they manage to build it?
How they? Is it Asia? Is it the end question yours? Is the big question? Yes, there is an architect.
I don't know. Man, the chin. Sikita. Okay. Spiral nature. The room it is 100% visible. It is in the room and per the livestones and the leisure the pillar. Okay? So called the backers are why you are using that because here you have the layer effect. Okay? Let's see. IFE. Okay, yes. Yes.
A good place on the prior picture. Those little areas that are way down below. Do you know about how big they would be? The areas that are there. No. The orange areas that hippies. Or if you're right, let's go down. Oh, that peer tips. Go figure those areas. Is there any speculation on? No. So what would be there? How large or at which depth? How large the buoys are or the areas are? Thank you for this question. We are studying it, but they are comparable with the largeness, with the dimension of the current.
So the chambers are the size of the pyramid itself.
The chamber is big like the pin. The numbers in its stick.
Is see. Is it say? Yeah. Let's go. This is insane. Well, that's an interesting observation, because what you're saying is that there's an area way down below, and I'm not sure exactly how far that would represent. 1.2 kilometers. 1.2 kilometers. More or less. One is a big dress, a totally open area. Yes. Wow. Yeah. We get well. Another, this is the old Coca. So keep. Make out pillars and roof. Make out. This is, please ask me the question, why we are not watching the abrupt variation? Because we have tuned the software to eliminate to avoid the defect of the water, and so we have this in order to enhance. We wanted to see how many pillars we are detecting. Yes.
So, side question. We've mentioned several times in the series of presentation a structure known as the Tomb of the Birds, NC2, which is the opening into a tunnel and cave network that runs below the Giza Plateau. This was explored in the very early 1900s, and they have stated that this tunnel system runs from the northwestern corner of the plateau and follows all the way below the central pyramid. This was by Sultan Caviglia, the early explorations.
Yes.
Have you turned the software onto the Tomb of the Bird tunnel system to corroborate the distance and depth of that tunnel and cave system? Because I, as well as many other researchers like Andrew Collins, believe that the Tomb of the Birds and NC2 are one of the access points into the subterranean system below Giza.
We are working.
Nice. Good.
They're working for us. Everybody. We are.
And I've been inside of that complex on a number of occasions, and it definitely goes further than we are able to currently explore in the lowest depths of the tunnel system.
Thank you for the question. Thank you. Thank you for being here.
Beautiful.
Everyone.
And thank you. You to share your knowledge.
Thanks. I don't know. This is important. I think it's the last because I don't know. Yes, this is very important because basically come on. We make a recap of the ability. We are linking, here we are watching several things. The spiral measure of the shafts, presence of the shafts, spiral measure of the shafts here. Okay? Look here. Look the sinusoid here. Look. Forza Pine. This is Forza Pine. Forza Pine. Okay. Roots. This is that relief that Corrado made. Is not in scale. So this has to be only to show how it is.
And I think you just answered a very important question. So there's also been some curiosity for the extrapolation from the data
into the 3D model. So who was responsible for interpreting the data,
all the team,
and creating
all the team.
so the 3D model is not AI generated.
No.
It's done by your team.
Filippo, Corrado, and Armando generated.
Okay, so you essentially studied the data and then built the 3D model yourselves.
Humans
Okay.
build
Okay.
the 3D is not AI model. From the scans, the 3D model. We use AI only to try and retrieve a sound that we had it also very high, some probabilities. They are AI. We in which probability we are watching this the AI give us the probability. Okay? Yes.
Have you had any other organization that you work with to vet your software?
I'm story.
Have you had is there any other organization that which have tried to vet your software? Yes, and work with it.
Thank you very much. It's very important, Giza. A foundation gave mandato musige. Set Professor Howard Zepger, full professor in Synthetic Aperture Radar of Stanford University to replicate the Doppler. Okay?
So they're working on replicating your software on the Giza Plateau or just elsewhere?
Just replicating the method.
I think they were to the method. So I feel the method. Just to prove that
Yeah,
well, if you are right or not.
Stanford is working replicating the method. If we are watching now, this epic op. I think that I am big time.
Wow. This city, bro.
È questa. I am destroyed.
Would you like to rest a bit? There's many questions.
Let's
No, you don't finish, you see.
because there is a very important thing that I have to show you.
Yeah, how you can miss.
You have time, huh? You have time.
Of course, we came for you here. We came for...
So we are collaborating with Trevor Grassi that I check here, and I thank him because he's a good guy, and we are also trying because we are working on our Giza. Okay, we know that in Giza there are shafts that are visible from the space. I've never been on Giza. I'm working on Giza at home in Corciano, Perugia, where Enebio. But I wish to go what that Giza. Allora, Trevor gave me this image where he shows several shafts that goes from the surface, goes below the earth, underneath. We found up with our tomograms that there are three places here, A1, A2, and A3, that are massively full of shocks. Here we can see that also from Google Earth. But here and here, no. Because they, in my personal opinion, this is all in my personal opinion, these structures are postume, sono state costruite di opera. Okay, so they're post-pyramid built, so they just correct the appearance of these shafts, these shafts. Here, they are visible. Ta-da! Shaft. If you live there, yes, see the shafts are blocked at a certain level. This one in particular, let's say this. This tomographic lines, then ta-da! Each shaft goes up.
Matas go up, matas. Another 1,000 to review. The one thing that's interesting, so we live in Egypt, and we've spent literally hundreds of hours on the Giza Plateau. So if you go back one slide, the area called the Western Field, where all of those mastabas are located, if you climb on top of those mastabas, you can still see down into those shafts. So if you look on each one of those little rectangles, there is one shaft in each one of those rectangular structures that goes down into the bedrock. And you can climb on top of them and see down in there.
Yeah, measuring that.
Yes.
We will publish these results.
And on your next slide,
And this is a validation.
correct. Those vertical shafts
Yes.
are also connected via transverse horizontal shafts, which is what you can see there. So this is very interesting that you're
The network.
correct.
They load what we are connecting whatever part of our mente. So we can go here, make a so-called un cantiere, come si dice? A safety cantiere. Should we dire, a query? No, you need to do because they are puppet. Structure query. We will make a static like a work site, a safety working site, no? And to go down, we can go down here, look, this is very simple. Here is tapped room, here, but after this is not tapped anymore. And go down, and revive here. And you can watch inside this room that is full of ticks. Yeah. Come and see.
It's the best. It's bigger. It's full of itties.
Listen. Poi là, poi ambizio. Ropas. Lo. Okay. So I told you there is something new.
Yes, but with this evidence, it seems like it's going to be impossible for traditional Egyptologists to maintain that this is built by Khufu and Khafre.
May I ask you to repeat? Please, yes, please.
Yes.
Yeah, with this in evidence that you presented today, it seems like it's going to be impossible for traditional Egyptologists to continue to maintain that these structures were 4th dynasty built by Khufu and Khafre and Menkaure. That would be my conclusion.
Yep.
Yes, it's a big one.
Your question has the answer. She's embedded with the answer.
In my personal opinion, the only answer is excavation. It's that we want to react the permits to drill on the Giza Plateau and to discover or to see, to watch with our eyes what lies beneath the presence. So we want the permits to go there and to start the excavation and to explore the networks beneath the earth. This is the only answer.
Yeah.
God bless you.
You're back there. And this is the 3D model that we are working on with Corrado Malanga. our professors.
Stanky.
I tell you that the work is absolutely not featured, and then I will tell you, we will discuss the agenda of the meetings that we are having from now into 1 year, where I think that one of the most important meeting, it was Malta, here, because here we are showing this.
Yeah.
And Maltese is showing.
Say, you know, yeah.
All right. Major follow-up coming up soon. Wait, there's one more.
It's no way. No, this is the last.
Is it Christmas today? This Christmas. This is Father Noel. Men. So, Menkaura here.
What is it?
Central Pyramid. Great Pyramid. Causeway. Possibly something below the Valley Temple and Sphinx here.
What's happening? It puts me one more.
Seems odd. All right. A lot to digest from today's presentation, and initial impressions will be that there will be some collaborations between the SAR team and the land of Kep. I just put a plug in for you. Thank you. These guys have been very accommodating, articulate, friendly, and I think they are honestly interested in an objective exploration of the Giza Plateau. So,
Document 8 is the shaft of the Sphinx, one shaft. Here we have the group of the shafts given by Trevor. So they are more than these, but we are indicating in the 3D only the shafts that we are sure that we studied, because we are scientists, as we put in the results, only things that we had measured. These are the shafts of Menkaure. Therefore, I'm sorry, of Numkufu, there are 8 like that. These are the shafts of Khafre with this scark sheets. Below, we get office that we didn't put empty because we did the deck.
What they have 8 as composed to the other ones.
They make our 4. And here we are. These are the 2 rooms that we saw on the shots of Trevor. Yeah. And so, the agenda of the Khafre Research Project activities are these. On the 27th of July, we will see in Spoleto, Italy. If you are interested, there is the flight that belongs from Lucca Airport from Malta to Perugia, and you can go in Spoleto, which is very near. Yes, and there is also a live streaming in English that we are organizing. And if you, I tell you in live here that you have to contact Francesco Liberati, and I will give you his contact. And then the last appointment is probably, but certainly, in June, May or June in Verona. And you can cut back Nicole Chico. In Verona, we will show at the end of the project, the end of the world.
Thank you for watching. Please like, share, comment, and subscribe to all of our channels, Ancient Odysseys, The Land of Chem, and Let's Go with Lex and G for all of our travel adventures. And please become a member for exclusive content and updates